Hello students, how are you? Today we are going to solve different binary operations exercises. Exercise number 1. Operation star is defined the set of real numbers by x star y equals to 2x plus y minus 3. Find the value of A 3 star 4, B 1 star 2 star 3. Solution. The definition is x star y equals to 2x plus y minus 3. Now point A, 3 star 4 is equal to, now we replace x by 3 and we replace y by 4. Then it is 2 times 3 plus 4 minus 3 equals to 6 plus 4 minus 3 equals to 10 minus 3, which is 7. B 1 star 2 plus 3. First we have to expand those brackets is equal to 1 star. We replace x by 2 and we replace y by 3 is 2 times 2 plus 2 times 2 plus y, which is 3, minus 3 equals to 1 star. Here we have 4. 3 minus 3 is 0. 1 star 4 plus 0 equals to 1 star 4 equals to, now replace x by 1 and y by 4. It is 2 times 1 plus 4 minus 3 equals to 2 plus 4, 6 minus 3 equals to 3. Example number 2. The binary operation star is defined the set of real numbers by a star b equals to ab minus 7. Is star associative? Roman 2. Is star commutative? Solution. The definition is a star b equals to ab minus 7. Then the Roman 1 is star associative. Now we need 3 elements, like a star b star c. Is it equal to a star b star c? Now we're going to check a star b star c. Is it equal to a star b star c? Here we have 1 and here we have 2. Only 1, just a star b star c is equal to a star b, it is ab minus 7 star c, okay, equals to, now we take this as a and c as b. How do we get now? Now how ab, it is like ab minus 7, it is a, ab, now it is c minus 7 equals to ABC minus 7C minus 7. Now let's check on expression number 2. A star B star C is equal to, first we calculate this, A star. Now take this B as A and you take C as B. Now get BC minus 7 equals to, now we take this one as B equals to AB. It is A BC minus 7 minus 7 equals to ABC minus 7, ABC minus 7A minus 7. As you see, one is different from just one is different from 2. Then conclusion, star is not associative. Because for the first case we have ABC, it's okay, ABC. Now we have negative 7C, then it is negative 7A, then they are different, then it is not associative. Roman 2 is star commutative. Yes, the definition say we know is A star B equals to AB minus 7. Now is A star B the same as B star A? Yes, just so this one is AB minus 7, which is equal to BA minus 7. As the multiplication is commutative, AB is the same as BA. Then conclusion, star is commutative. Exercise number 3. Operation T is defined in R star by xty is equal to xy over 2. Show that R star under T is an abelian group. Solution. Before showing that R star under T is an abelian group, let's first explain what is R star. Just we know that set of real numbers is defined as an interval of negative infinity to positive infinity excluded. Just R star, just it is all real numbers except 0, which means that 0 is excluded. Then R star is defined as, now I have an interval minus infinity to 0 excluded union 0 to positive infinity. Okay, now let's show that R star under T is an abelian or commutative group if the following 5 properties are verified. The first property is closure property is a closure property. Remember that verify this you have just for all x, y member of R star is x t y member of R star question mark. Just this property, it is verified. It is verified because for any element, just you see that x t y is equal to x y over 2 for any element of R star that we should replace to x or y, then we get also an element of R star. Just for any element that you should replace x and y, we are able to get an element of R star. Then this property is verified. Property number 2 is associativity. Associativity. Now we have 3 elements. You have to ask ourselves if x t y t z is equal to x t y t z. Now have 1, then 2. Now I have to calculate 1 x star y star z is equal to, remember that the definition is x that is t, x t y is equal to xy over 2. Now xty is xy over 2. Now star z. Now here we have to take this t, sorry, we have to take this as x and we have to take this one as y. Then this one is equal to because we follow this definition here, it is x t y is equal to xy over 2. Now we get x is equal to x y z over 4. So that we get. We verify on 2 we have x t y t t z is equal to x t. First verify, we calculate this by replacing x by y and replace y by z. Now it is yz over 2, which is equal to, we apply also the definition, we maintain x, take this as x, then we take everything as y. Now we get x y z x y z over 4. Therefore, since 1 is equal to 2, now the associativity is verified. Property number 3 is identity element. Is an identity element exists. Now identity element E. Now here we need to check for any element x of R star. Just for all x member of R star, there exists E, which is a member of R star, such that x star x t E is equal to E T x, then you get x. Whether you can use this one or use this. Let's use the first one. X T E is equal to x. Now remember the definition is that we have is x ty equals to xy over 2. Now this one is x, then we replace e by y, replace y by e, then we get this one is x e over 2, which is equal to x. Now simplify, it remains e over 2 equals to 1, then cross multiplication, e is equal to 2. Now an identity element exists and it is equal to 2. Property number 4. Now property number 4 is inverse element. Now for all x member of R star, there exists x negative 1, which is an inverse of x, such that also this x negative 1 is a member of R star, such that x t x negative 1 is equal to e, which is an identity element, still equals to x negative 1 star t x. Now let's do this one here. X t x negative 1 is equal to e. It's equivalent to saying that I will apply this definition here. It is x negative 1 over 2, which is equal to 2, because our identity element is equal to 2. Then you get, now we need x negative 1. X negative 1 is equal to 4 over x, leave x different from 0. And even we know, because while in R star where 0 is excluded, automatically x should be different from 0. Then we conclude by saying that an inverse element exists. Just we are able to find the inverse of any element, because just you have 4 over x where x is different from 0. Just we are able to find the inverse of any element. For example, the inverse of 2 is 4 over 2 equals to 2. The inverse of, for example, -5 is 4 over -5, which is -5 over 4. Then conclusion, an inverse element exists. Just up to here, since all those 4 properties are satisfied, then R star under T is a group. Then to verify if it is an abelian group, we need to verify property number 5, which is commutativity. Now just what is for all x, y, member of R star is x star y is x ty equals to y star y t x. We have to verify. Definition that you have is that x ty is equal to xy over 2. Now y t x the same is y x over 2. Since the multiplication is commutative, just have xy the same as yx, therefore they are equal. Then the commutativity is verified. Now conclusion, R star under T is an abelian group. Now you have exercise that we try to do. The first one, here we have a center E, which is equal to 1, 2, 3. Then you have the carrier table here. Question number A, find the identity element. 2, you have to solve the equation x star 2 equals to 3 Roman 2, 1 star x is equal to 2. Number 2, let cent G equals to 0, 1, 2, 3, 4, 5, and the T be a binary operation which is defined by ATB equals to A squared plus B minus 1. Then we have to construct the carrier table for the operation T. Number 3, you have to find the identity element for the operation star defined by x star y equals to x plus y plus 2.